Welcome back. This is the day the Lord's made. Let us rejoice and be glad in it. So, for our last unit, we're going to be talking about electricity and magnetism. And so, we're going to start with electricity. And so, to get us started here, again, going back to what we already know about chemistry, um, the world's made of atoms, and those atoms have protons and electrons and neutrons. In this unit, we're pretty much going to focus on just what the electrons are doing, which is what we always do in chemistry anyway. So, so some general knowledge again of conductors and insulators. Again, some words we've heard before. A conductor is something that easily lets electrons move around. So when you think about something that conducts, it's something that easily lets electrons move from one place to another place. In general, you should be thinking that metals are conductors. The best conductors are silver, gold, and copper. Now, we don't use silver power lines because if we use silver power lines, people are probably tempted to cut them down and sell the silver. Although when the price of copper goes up, that does happen. But anyway, we use copper as our typical conductor for power lines. If you're not a metal in this class, you'll be considered to be an insulator. Not all insulators are created equal. We'll talk about that more in a few seconds. But again, the big idea is some things are conductors, some things are insulators, and it all comes down to whether you let the electron move or not move. You can think of this also connected back to chemistry. What's ionization energy? Is it hard to pull electron away? Since nonmetals tend to hold on to electrons pretty tightly, they're not conductors because they're holding on to them. It's hard to pull them away. So some other things just to be aware of. Salt is not conductive as a solid, but as a liquid it is. So if you have like a battery that's not working, it might just because the salt has some formed on the anode or the cathode, and so that little layer of corrosion is stopping the charge from moving. So now salts, if they are liquid, would be conductive. But with the salt, the positive and negative charges are stuck in place and they can't move. Again, another common misconception is people think pure water is conductive. It's not. All right, pure water is an insulator. However, it's hard to find pure water. Almost always you have some almost always the water has some like salt inside of it. So if you put a little salt into it, then you have a conductive solution. Now we can talk about charging things by having electrons moving around. So when things come in contact, electrons might transfer back and forth. It depends on what's coming in contact. We should mention that in general, like if you're going to go to the park with your kids, take it from a dad here, you choose the slide based off of the season. When it's the summer, you are able to go down plastic slides. That is totally fine. But during the winter, you don't want to go down a plastic slide. If you go down a plastic slide in the winter, you're going to get shocked. You're going to get shocked because when you go down that plastic slide, since you're in contact with the plastic, electrons will be transferred back and forth, and you're going to pick up a net charge, which means when you get out the end of that slide, you're going to get zapped. Now, if you're Mr. Love's kids, what that means is during the summer, you don't have any fun, but during the winter, when you go out on that plastic slide, you high-five your dad at the bottom so you get zapped. So, but that's a side story. So the big idea is when things come in contact, electrons go back and forth. It comes down to how much you like those electrons, electron affinity. And so we can consider, like on the periodic table, if we rub two things together, two elements come in contact, who grabs electrons? You're thinking probably fluorine, big bad bully, he takes electron. That's correct. So if you have like a bunch of halogens on you, that means when you come in contact, there's a good chance you're going to be pulling electrons towards you. So we have this thing called the triboelectric series, which helps us determine who picks up the electrons. Oh, I should mention too, I didn't mention this a few seconds ago. During the winter, you should go down the metal slides because when you're going on a metal slide, you can't pick up a charge because the electrons just move out of the way. So sorry about that. Anyway, you see on this triboelectric chart, it basically tells us who is going to gain or lose electrons when they come in contact. So again, not something to memorize, but I'll have a chart for you. Here we have a very brief chart. At the top of the chart, we have polyvinyl chloride, PVC. It basically, when it comes to contact with other stuff, it's the one that tends to pick up the negative charge. It's going to grab the electrons. On the bottom here, we have your hand. So this is an incomplete chart, but basically what this chart says is as things come in contact, whoever's higher on the chart gets to pick up the electrons. If there's any exchange of electrons, it's going to be going towards the top of this chart. So PVC is at the top, polyester, rubber, cotton, paper, silk. Towards the bottom here, we have your hair, your hand, glass. These things would tend to lose and get positive. Quick note again, it's not the protons, it's the electrons moving. All right, also we should mention too, once things get charged, you have positive and negative charges, then they can either attract or repel things. We should remember that opposites attract and similar things repel. So something positive, something negative will like each other, something that is both negative or repel each other. If you're neutral, you can be attracted to either positive or negative. So when we talk about things coming in contact and transferring charge, we call that charging by conduction. So anytime things actually contact each other, that is electrons being transferred directly from one to the other, that is conduction. So if something's negative, touches something that's positive, the negative electrons will transfer to the positive thing to balance out. So I'm going to talk about that down here. So again, charge by conduction, if you had two metal spheres, one with a positive 10 charge in coulombs and one that was neutral, and they came in contact, the electrons just transfer. This is charging by conduction, just balances out so that both spheres have the same charge. Another way to charge things is by charging by induction. Induction is when they don't actually touch, but they can induce a charge onto something else. This is kind of like your mom tells you to do something. She's not going to physically force you to do it, but she'll use her influence to make sure it gets done. This is like induction. All right, so if something is charged and it comes near something that's neutral, it can cause the electrons there to rearrange themselves and induce a certain charge on it. It doesn't change the charge unless it gets grounded, but it just rearranges it. So an example of this would be if we had some positive rod come near some neutral metal sphere. So at first, when the positive rod comes nearby, what's going to happen is the electrons on this sphere are going to rearrange themselves. They've been influenced to rearrange how they've been before. Again, even though this thing has a negative positive, it's not like the protons are moving to the right. What's happening is the electrons that are over here are moving to the left. So don't get the misconception that protons are moving here. It's just electrons rearrange. So if this positive rod gets removed, then it'll go back to just being spread out evenly. However, if the positive rod stays by and we ground the sphere, what's going to happen? And by ground, we mean something else touches it. So here we have something else that make contact. It could be your hand, could be anything, just that comes in contact with it. That gives a chance for these positive charges to leave. Again, it's not really the protons leaving. What's happening is electrons on the ground or from you are being, hey, dude, there's something positive here. Let's all go up there. And so the electrons come on up. And now what we have is we have less positive on the sphere. And if we remove the positive rod, then we end up having a negative charge here. So you might think of it in terms of conduction versus induction. If you charge by conduction, what happens is the charge will balance out. And generally what happens is if you charge by conduction, they both end up with the same charge. So if something positive becomes something that's neutral and they touch, they both are positive. With induction, you get the opposite. A positive charge will cause something that's neutral to become negative. So that's the big difference between conduction and induction. Now with electrons going around, we can calculate the actual charge on the atom. Now generally in physics, we still often just talk about like we do in chemistry. +1 charge, -1 charge. Look at the periodic table like sodium's column. The alkali metals, they tend to pick up a +1 charge. And that's the lazy chemist way. We're like, oh, the halogens, they pick up one extra electron. That's a -1 charge. Now, I'd put this actually into coulombs, which will be the unit we'll be using for this unit. We have a magic number, and that magic number is 1.6 times 10 to the -19th. So protons have a positive 1.6 times 10 to the -19th charge, and electrons are negative 1.6 times 10 to the -19th. So back to our periodic table, Na, he usually picks up +1 charge in chemistry. He has one extra proton than electrons, so at net, a positive 1.6 -19th. Oxygen commonly has a -2 charge. It has two extra electrons, so it has more electrons than protons, so it picks up a negative charge. It should be noted that nothing can have a charge other than a multiple of this, which means it's not possible to have a charge in between positive 1.6 and positive 3.2. Either you have the electron or you don't have the electron. Charge can also be measured in amps, and this is very common for your house when we measure electrons moving around. Amps is actually a measurement of how much current is moving per second. 1 amp is defined as 1 coulomb of charge per second. So at your house, a typical line will let like 20 amps or 30 amps through. So that's like saying we're only letting this many electrons move through at one point. So since an electron, if it is electrons, has this charge, it should be negative. That means that 1 amp means that approximately 6 billion times a billion electrons moving per second. Now we should note that it doesn't have to be electrons moving. It could be something else that's positive or negatively charged. Like in our body, we just use potassium and sodium ions. they're your favorite electrolyte. Our body makes electricity by having positive, negative charges move around the body. And so it doesn't have to be an electron. It could be a positive, negative. I'm going to stop this one for now and move on to the next one. God's peace.